All right. We left off on 2.4. So I'm going to continue 2.5, but to do a quick quiz. So here's your quiz. Graph y equals negative 2x minus 3, but graph it using slope-intercept form. And second question is identify the slope and the y-intercept of this linear equation. So pause it if you want to do it, but here's your quiz. Email it to me as a PDF, and we might take another test soon. Maybe over the weekend or on Monday, but I'll email everybody about that. But now let's continue with 2.5. So with 2.5, we're going to focus on is just being able to write a linear equation. Equation. What I mean by writing a linear equation, they usually, in this section, these problems, there's three types. There's three different types of problems. One is, in all these situations, they ask you to write, or they might ask you to describe, they might ask you to find, they might say, what is the linear equation? Write the linear equation, find the linear equation, describe the linear equation. It's all about looking at a linear equation. Linear. So, but the three different ways they ask the question. The first one is they're going to give, you're going to have a slope and a point. So these are all the things that are given. The second one, you're going to have 2 points. And remember, what I mean by point is that x comma y. That's what I mean by point. Ordered pair, so on and so forth. And the third thing is you are given a linear equation and a point. So in all three situations, you're always given at least 1 point. You're always going to need that. And then in one situation, you're going to get a slope with the point. Another one, you're going to have 2 points together. And the other situation, you're going to have a linear equation with a point. And remember, a linear equation, you can think about it as y equals mx plus b. Or remember, m is your slope. M is your slope, and B is your y-intercept. But when I mean y-intercept, remember, all y-intercepts have a 0 on the x and some number on the y. Usually that number is the B that goes there. So don't forget that. There's only two special, and oops. Sorry, I moved the camera, so I'll just pause it for a second. So these are the three cases that we're going to look at. And for each single case, if we're going to be writing a linear equation, we're going to need a formula to help us write this linear equation. And this is the formula I always use. Always use. So I'm going to box it over here. Put it, it's called point slope form. And it's y, so y minus y sub 1 equal to m times x minus x sub 1. So here's important. I'll box it. This is called the point slope form. The reason it's called the point slope form is because here is your point. X sub 1, y sub 1. That is the point. And then we have our slope. And that's why it's called point slope form, because you need a point and a slope to be able to use this formula. So that's why it's important. In all these situations, you have a point, at least one. Here you have two, but you still have a point. Here you have 1 point. So you're always going to need this. We're always going to need both of them. You're always going to need a point and a slope. In the first one, it's going to give you the slope right away. And we're going to look at an example of that. We're already given the slope. In the second situation, we don't have a slope explicitly. But if you remember from the last video, that if you have 2 points, with 2 points that makes a line, or you can do a lot of stuff with that, but when you have 2 points, that's enough to make a line. That's also enough to help you find a slope. I hope you guys remember we talked about the slope formula. So in this situation, you literally will have the slope and the point, and that's it. In the second situation, you have 2 points, which I only need one. Doesn't matter which one of the two, and we'll see an example of that. But you need the slope. And the slope formula, if you have 2 points, helps you find a slope. In the third case, again, we have the point, but we need a slope. To be able to use this formula, you're always going to need a point and a slope. So where do I get the slope? The slope comes from sort of like the second one, is that even though there wasn't a slope here, you can find the slope because you have 2 points. Same thing with the linear equation. Now I don't have 2 points, I can't find the slope. But with this linear equation, I know this linear equation has a slope, and I'm going to use this slope to help, and the point, to help me find the linear equation that I'm looking for. So, but like I said, in all these 3 situations, we always use this formula. And even though I said always so many times, there's actually sort of 2 cases, and each one of those cases has its own case in terms of when we don't use this formula. Like I said, I'm always going to use it, but there's only 2 cases. So I'm going to put down here a note. We don't use, I'm going to write it in words. We don't use point slope form when the linear equation is vertical or horizontal. I think I'm spelling this wrong. I think it's a O. But yeah, that's the idea. Hopefully you can read that. We do not use the point slope form when the linear equation is vertical or horizontal. The reason why is because whenever you're looking at a horizontal or vertical line, remember, that's over here, I should have closed the cap. All vertical lines are when y is equal. So and when x is equal to a constant. All horizontal lines is when y is equal to a constant. So we'll use the point, and look, the point has an x and a y. The constant that the vertical line is going to be equal to is the y coordinate of that point. The x coordinate of that point. For the horizontal line, the constant for y to make a horizontal line will just be the y coordinate. And I'll show you examples of that, of what I mean. But this is the overall gist of what this section is about. We're going to be writing equations, and we're always going to use this formula, except in these cases. If we're talking about vertical or horizontal line. Not only does that talk about when x is equal to a constant, but remember, the slope of all vertical lines is undefined, whereas the slope of all horizontal lines is 0. So it's important to remember that. Okay, that was a lot. I'm cramming up in there. All right, but let's look at an example, just so you can see what I mean by writing these equations. So here, you might have seen that flip really quick, but I didn't want to copy this whole thing down, so it's like the quickest way I can do this. So here's the example. It says, the idea is we're going to write an equation of a line given a point and the line and the slope. Write the equation of a line given a point on the line and the slope. So that's what I meant. That's the very first case, that you're given a point and the slope. So read the question, use the point slope formula. Well, that one's already telling us to use it, but like I said, I'm always using it regardless if it tells me or not. The only time I don't is if we're talking about vertical or horizontal lines, which it can be talking about a vertical or horizontal line implicitly by it'll give you a point, but then maybe the slope is 0. And that should start priming your thinking to say, oh, there's going to be a horizontal line. Or they might give you a point and say that the slope is undefined, which again, your mind should be going to the fact that all vertical lines have an undefined slope. So, or they can just say find the equation of a horizontal line, and that automatically says you're going to use the other formulas, either y equals c or the x equals c. But here it says use the point slope formula to find the equation of a line passing through. So there you go. There's a point and having a slope of -4. Write the answer in slope intercept form. So don't mix up point slope form with slope intercept form. So because point slope form, you need a point and a slope. Slope intercept form has a slope and the y-intercept. That's why it's slope intercept, and the other one's point slope. So slight differences. So let's try doing this example here. But let me pause really quick, and then we'll go back to trying the example. So I'll zoom into the example, just so we didn't look at the answer, and we can just focus on doing the example. But I somehow misplaced my marker. Alright. So the question gave us a point and a slope. That's this formula here. So again, automatically, the first thing I'm always thinking about, if it asks me to write the equation of a line, it said nothing about vertical, horizontal. It said nothing about undefined or 0 slope. Actually, the slope was -4. So that voids this thinking. That means I'm going straight to using the point slope form. So it's y minus y sub 1 equal to m times x minus x sub 1. So I need my point. And if we remember from the question, so I'm going to pull it up. The question said the given information is 2, -3. Again, if you want to verify this, you can go pause the video, rewind it, and go to the point where it actually gave the point and the slope. And the slope was -4. And it actually wants you to write your solution. That's really important. Once you write your solution in point slope form. So your solution in this is slope intercept form here, because there's your slope and your y-intercept. This is point slope form. There's also the standard form, and that one was with capital AX plus capital BY equals C. But now all we need to do here is just plug in the point and plug in the slope, and that's it. So it's going to be y minus, and then parentheses, I'm going to plug in that y sub 1 is equal to parentheses, I'm going to plug in the slope, x minus, and then parentheses one more time because I'm plugging that x minus 1. So here, that's my x. So that's going to go in here. Don't forget, these negatives come from the formula. This too is coming from the point. Then we have our y. Let me use a different color just so it pops out. Our y is here, which, remember, your y is -3. This negative is coming from the formula, whereas this negative is coming because of your point. Now, we just need the slope, which the slope is -4. So technically at this point, you have the equation. It's not simplified, but you have the equation that's going to pass through this point, but have this exact same slope of this line. So that's pretty much all you would have to do. But if you remember at the end of the question, it did say write the answer in slope intercept form. And if you want to go back and look at the question, it says that right at the end. Like I said, this is slope intercept form right here, where y equals mx plus b, which we were using last week to help us graph a linear equation. But to do so, we had to isolate this y. This is going to give us, these two negatives are going to become positive, leaving me a y plus 3 equal to, here this positive and negative aren't going to change. This is still going to be x minus 2, but then I will distribute this -4, which will leave it with -4x. And then I'm going to end up multiplying this negative with that negative, which will leave me with a positive 8. An all slope intercept form is, make sure you isolate your y. That's the slope intercept form. We have to isolate this y. To do that, I subtract 3 to both sides. On this side, this cancels. Here, we're going to simplify these, which leaves us with y is equal to -4x plus 8. And that's our linear equation that passes through this point, has this slope, and we wrote your solution in slope intercept form, which is what the book wanted. And there it is, exactly. And the rest work the same. You're always going to just plug in your point and plug in your slope. Again, I'll give you some homework so you can try, but this is what you're always going to do. As soon as it's saying that you're going to write a linear equation, automatically start taking point slope form. Unless in the question you see somewhere that it says the slope is undefined, the slope is 0, or if it's directly asking for a vertical horizontal line. So those are just key things to watch out for. Now here's a second example. So if you guys want to try an example of this, just switch the point and slope around. So try using, so let me use a different color for that. If anyone wants to try it, I'll box it right here. This is try. That would be try with -5 for the x, 2 for the y, and then our slope is -3. And then make sure you write your answer in slope-intercept form. Again, if you want to try it. If not, it's alright. You'll do some homework on this. But now let's look at how it is with 2 points. It's going to be very similar in terms of once we had the point, we just plugged in, but we need the slope as well. So that's the part that's going to take most of the work with these examples. The first one, it was plugging it in, moving around, talking about it, but the 2 points actually involves more work because, let me sort of close this off here. So the difference is for the second type, we're going to need the slope formula. And hopefully everyone remembers it. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's our slope formula. So we get to use. But to use this formula, you need 2 points. So again, the nice thing is in these questions, you're going to be given 2 points. You need 2 points. Here you need a slope. That formula helps you find the slope. And so on and so forth. Let's look at an example. So here's the question. Write an equation of a line given 2 points. So again, that's the second one. Using the point slope formula to write the equation of the line passing through 4, -6 and -1, 2. And again, it wants you to write your answer in slope-intercept form just like the last one. So if you want to pause the video and go back to see what those 2 points are, the 2 points were 4, -6 and -1, 2. So we'll use, remember when we were finding the slope, I told everyone that you have to make sure you label it. It doesn't matter which one goes where, but it's better to just make sure you label which ones are going where so you don't mix them up later. So we have let this be x sub 2, y sub 2. So when I plug in y sub 2, it's going to be 2. And then we have minus. Don't forget, the minus is coming from the formula. And this minus is because the y coordinate is -6. So I'm going to put that in parentheses. And then for the denominator, we have x sub 2, which is -1, minus. Same thing. We have our y sub 1, which is 4. And this is going to simplify to, these two are going to become positive, which is going to give you 18. These two are going to be positive, which is going to leave you with 4. So if you notice, I made a huge mistake here. Granted, it's a little late, but even though this becomes positive, 2 plus 6 does not give you 18. It's just going to be 8 over. And if you notice here, I said negative times a negative is a positive. These aren't multiplying each other. So I'm going to just cross this out completely. I don't know what I was thinking. I had a brain fart. So these two do become a positive. But that's just going to be 2 plus 6, which gives you 8 over. And then this negative with these parentheses aren't doing nothing. This is just going to be negative 1 minus 4, which leaves you with a negative 5. And once you've done that, you're pretty much done with the problem in terms of difficulty. What only is making this one a little more difficult is possibly having a fraction in it. But we now have a point. We actually have 2 of them, and this is the point I iterate again. It does not matter the order of which these are. You could have easily have switched them around, and it does not matter. So let's finish this example. So we did the first one. Now we're here in the second one again, just to reiterate it. But we always are going to need a point and a slope. We have 2. It does not matter which one you use for the formula. Again, we use a slope formula, but we need the point slope form. Y minus y sub 1 m. Can you still see that? Ooh, I forgot to zoom out. I had zoomed in because of the question. So we need this, but again, I need the slope, the point, and the slope. And it doesn't matter which one of these you choose. I'm going to pick the second one. Only because the numbers look nicer. That's the only reason why I'm picking it. And now I'm just going to plug into this. And let's see what we get. So I'm going to have y minus, and then y sub 1 is equal to m times x minus. And I'm plugging into that. Oh, I forgot I'm supposed to plug into the slope as well. So I know my y coordinate is 2. My x coordinate is negative 1. And then just slightly cross that out. My slope is negative 8/5. So I know these are going to become positive. That's going to leave me with y minus 2, because nothing's simplifying on this left-hand side. And then I have to distribute this to both of them. So there's going to be negative 8 over 5x. But then I have to multiply this 1 by negative 5/8. And 1 times anything always leaves you with the same number. Like I said on the previous one, the last part of the question is ask you to write in slope-intercept form. So to do that, I need to add 2 to both sides. But these are both numbers. There's no variables in front of them. So I actually can combine like terms with this. Let me do that on this sheet of paper, just because I don't want to sort of continue somewhere else. So to have negative 8 over 5 plus 2. Remember, to be able to add fractions together, they have to have the same denominator. And the denominator right now for 2, for any whole number, is always 1. So for these to be the same, I'd have to multiply the denominator by 5 and then the numerator by 5. That gives you negative 8 over 5 plus 10 over 5. And now we can actually combine these. Don't forget, this one's negative, so we have to subtract these from each other. So that's going to be 2 over 5 is going to be where is that going? Where are we at? This is going to be this new part right here. So that's going to become, I'm trying to find room of where to put this without having to erase everything. I'll just continue on the new sheet. But we do have this already though. How we did the work for simplifying this. And we know for sure this definitely cancels here. And we need to just simplify it. So we would be left with y is equal to, and we already know slope is negative 8/5. And then we have, from we just our calculations, we have 2/5. And that's pretty much it. Again, if you want to try one, you want to try another example, just try doing it with 2 comma negative 5 and 7 comma negative 3. And just make sure you're watching out for slope of 0 or something that gives you a 0 in your denominator and that's undefined. Just because the slope does involve a fraction, so you want to be careful. Sometimes they might not tell you that you're dealing with a 0 slope or undefined slope. Sometimes you might have just 0 in the numerator. You have to remember 0 in the numerator makes everything 0. But if you see a 0 in the denominator, that means undefined. You just want to watch out for those things. But the first two are pretty straightforward. The first one, for all of them, you need a point and a slope. The first one gives you the slope and the point, which is all you need. The second one gives you 2 points, which it's implicitly giving you a slope. It's just you have to work for it a little bit. You have to use a slope formula, and then you end up with a slope. And all you have to do is write the equation. And as long as it's not talking about vertical, horizontal, or slope 0 or undefined slope, we're using point slope form every single time. But now is that third option. That third part about they give you a linear equation and a point. That one's a little trickier. That one we have to have a small discussion, small recall of the slope-intercept form. So even though we talked about it, I want to talk about it again. We have to remember that when our y is isolated. So that's really important. Because if our y is not isolated, then we're not dealing with the slope-intercept form. Like here, we had to isolate that y to put it in slope-intercept form. Don't forget, this is the slope of the line, and this is the y-intercept, which would look like 0 comma b, because whatever b is. Sort of writing crooked for some reason, I'm not sure why. So you have to be able to, because we need a point and a slope. So to find the slope of a line, if you actually know what the equation is, you can find the slope of that line. Again, if you want, you can try using points. That works perfectly fine. Or you can just, even here in this last example, I know what the slope of this linear equation is. My coefficient of x is always going to be my slope. And I was only able to identify that because my y is isolated already. Whereas if maybe here, maybe something was going to change your slope. But something that definitely changes, if you thought this negative 5/8 before we added the 2, this, you might have thought this negative 5/8 could have been your y-intercept. So that's why it's important to make sure you isolate your y first, then identify what the slope and the y-intercept may be. Because as long as we have the point and the slope, we should be able to find a linear equation. But these questions not only give you a whole linear equation plus a point, they also ask a little bit more information than these last couple examples that we looked at. And the little bit extra information has to do with knowing if something is parallel or perpendicular. So that's what the next questions ask. The next questions are still asking you to write a linear equation, but the information that's given, let me say that again. So they're asking you to write a linear equation, but they're also asking for a little bit more information here. The last two examples, just write the linear equation, or just write the linear equation. Here, it's not only telling us to write the linear equation, it's also going to tell us to be parallel or perpendicular to something. So you have to remember what parallel means. Geometrically, meaning in a graph, parallel means two lines that never intersect each other whatsoever. They're parallel to each other forever. They're never going to cross. So that idea of something never crossing, but at the same time, it can't be the same line, because then that means they're overlapping each other. I want to be able to create this separation between them. And the only thing that creates that separation is your y-intercept. So it's important you understand the difference. So parallel, if you think, look, have this same angle here, but instead of calling it an angle, we call it a same slope. So if we put these two, they're definitely not the exact same line, because if they were the exact same line, they would be overlapping each other. But here, we can definitely see that they are parallel to each other. So they have the same slope. But to create this distance between them, so this one isn't overlapping itself, we have to change something up. So we already know for if the equations are parallel, they have the same slope. But they have to have a different y-intercept. Because if it was the same y-intercept, again, I say it one more time, it'd literally be on here. So you need to be able to create this separation. But the slopes are always going to stay the same, but the y-intercepts will change. But that's just what you see visually. You can say they never cross, saying that the slopes don't intersect each other. That's a little bit more information, but this is the idea. For two equations to be parallel to each other, they have to have the same slope, but a different y-intercept. So you want to watch out for that. Alright, so on a graph, that's how parallel lines look. This description here is talking about the actual linear equation, the way it's written. So this part will be exactly the same, but the y-intercept will have to be different. If you're looking at a graph, all you have to see is that as long as they don't do this, then they are not going to be parallel to each other. So that's how they look to be parallel. But here, this is describing actually writing the equation. This is if you're looking at a graph and you see the two lines. Now, perpendicular, if you're looking at a graph, perpendicular is like this. If I can get it to be, but there. It makes like a perfect cross. And geometrically, what that means is these angles, all these four angles here are right angles, meaning they're 90 degrees, 90 degrees, 90 degrees, and 90 degrees. They're perfect. But that's if you're looking at a graph. If you're trying to look at the equation, let's say if you're looking at two equations, there's only one here. Let's say if we had a second one, because that's what we're going to be doing right now. We're going to be finding a second one that's parallel to this. Or we're going to find the second one that's perpendicular to this one. If it was parallel, these numbers here would be exactly the same. If it was perpendicular, these would be, if they're parallel, these would be exactly the same. These would be different. But perpendicular, there's a little bit more than that. And it's mainly focused around the slope. So perpendicular doesn't care anything about the y-intercept. It mainly cares about the slope. And the slopes are reciprocal of each other. And if you guys remember what reciprocal means, that's AB and then B over A. So that's like that flipping. That's what reciprocal means. And not only will the slopes be reciprocal, all the slopes have opposite signs. So by opposite signs, I mean this slope, if this was -8 over 5, a perpendicular slope would be +5 over 8. And that would be, and it has nothing to do with the y-intercept. It's strictly just the slope. The slopes would be reciprocal of each other, so instead of 8 over 5, it would be 5 over 8. And the sign will turn into a positive. If it was positive, it would just switch into a negative. So these two things happen. For parallel, the slopes are the same, but the y-intercepts are different. So let's look at an example of that. So here's the question. Write an equation of the line passing, again, we have our point, which is what we need. So we write an equation, let me put that in view. Write an equation of a line passing through the point -4, 1 and parallel to the line defined by x plus 4, y equals 3. Write the answer in slope-intercept form. And we don't have to worry about standard form. It's too much work to do that. But here's the question. So we're going to write an equation of a line. Like I said, they give us a point and an equation. So this is the last type of example. And they want us to be parallel. So it's adding a little bit more than just writing the equation. But that's the whole point. It gives us a point and a line. So we'll do this example. Let me block this up here. So let me write the given information that we have. So our point that we need to pass is -4, 1. The equation that they gave us is x plus 4y equals 3. And we want the new line to be parallel. So if it has to be parallel, we have to think about this information. And something else that we know again, this isn't talking about a horizontal or vertical line. This says nothing about slope 0, says nothing about an undefined slope. So that means I can use y minus y sub 1 equals m times x minus x sub 1. Now, I need my point and my slope. But, like I said, they're always going to give a point. So that part's always going to be done for us. The part that we need to be always do is find our slope. There was only that first example that we did that our slope was actually given. So let's go through this. But I'm going to find my slope by using that equation. I'm going to use this to help me find my slope. Because I want this new line to be parallel to this first line. So to do that, I needed these two slopes, whatever the slope of this line is, has to be the same one. Remember, same slope. So this example, if the slope was negative 8 over 5, I would literally use negative 8 over 5 here in this example. But I'm not using this equation, I'm using this equation. And again, don't just like, oh, let me look at the coefficient of x. You're not doing that. Before you can identify the slope of a linear equation, it must be in slope-intercept form. Slope-intercept form, which that means I have to isolate my y. So to do that here, let me just rewrite it. So x plus 4y equal to 3. I'm going to subtract my x to both sides because I want to isolate my y. That leaves me with 4y is equal to, and just to keep it in the same order, I'm going to write the x in front with a negative. And my 3 I know is positive. And then I'm dividing not only the left-hand side, but the entire right-hand side. Which then the 4 simplify to 1. And now I'm left with y is equal to. The only issue is here, it's sort of hard to define the difference between the two terms. But if you remember in one of the videos, we talked about how you can break this apart into two fractions, which would be negative x over 4 plus 3 over 4. And now I have my slope. Again, don't just think it's this invisible 1 in front of the x. It's actually including that 4 as well. So you want to be careful. A lot of people just pick the x and completely forget that there's a number in the denominator that's still part of your slope. So the slope of this line, again, this I haven't plugged anything in here. The slope of this line is equal to negative 1 over 4. The parallel slope, so the slope I'm going to use for here, something I didn't say, so the notation for parallel is these two dashed lines. So the parallel slope, and for parallel slope they need to be exactly the same. So I'm going to write it again. But this helps me distinguish the difference between the equation that was given versus the equation I'm trying to find. So there's a difference between that. And again, even though I wrote the same thing twice, I always like doing this. I write with the slope that I got from this line, and then